Hi everyone. Today we are going to see voltage and current division rule. Normally this voltage division rule is applied when the circuit consists of resistor connected in series, and current division rule is applied when the circuit consists of resistors connected in parallel. Let us see voltage division rule for the circuit consists of resistance connected in series. Here in this circuit we have the resistance R1 and R2 connected in series with the voltage source V. The voltage across R1 is V1, the voltage across R2 is V2, and we need to note that the same current I will flow through both the resistor. The applied voltage V must be equal to V1 plus V2. So V1 is the voltage across R1 and V2 is the voltage across R2. So the applied voltage is divided between R1 and R2. That is the voltage division rule. Now we need to find out what is V1 and what is V2. Here V1 is the voltage across R1 is given by R1 divided by the total resistance R1 plus R2 into V. Similarly, the voltage across resistance R2 is given as V2, which is R2 divided by R1 plus R2 into V. So in the voltage division rule, the first step is to find out the equivalent resistance of the circuit. Here the two resistors are connected in series, therefore the equivalent resistance or equivalent is given by R1 plus R2. Therefore we can say the equivalent resistance of any number of resistors connected in series is the sum of the individual resistance. That is, consider n number of resistors connected in series. Therefore, we can say R equivalent is R1 plus R2 up to Rn. Therefore, from the circuit, we can modify as R equivalent, which is R1 plus R2. Therefore, the voltage across R equivalent at V must be the applied voltage. Now let us see the current division rule, which is applied to a circuit with the resistance connected in parallel with the voltage source. So consider here the resistance R1 and R2 are connected in parallel with the voltage source V. Here the same voltage V will appear across R1 and R2, and it is having different currents I1 and I2. This I1 and I2 will give you the total current I. When resistors are connected in parallel, like in this case, R1 and R2 are connected in parallel, we can write the R equivalent as 1 by R equivalent is equal to 1 by R1 plus 1 by R2. That is R1 plus R2 divided by R1 R2, and R equivalent becomes R1 R2 divided by R1 plus R2. So this is the equivalent resistance when the two resistors are connected in parallel. And there is important points to note in the case of resistors connected in parallel. The first one is when R1 is equal to R2 is equal to Rn is equal to R. That is, if the resistors having the same value which are all connected in parallel, then your equivalent resistance is equal to R divided by N, where R is the resistance value and N is the total number of resistors connected in parallel. And the point number 2 is the R equivalent obtained is the smaller than the resistance of the smallest resistor in parallel combination. For example, if you have R1 is equal to 10 ohm, R2 is equal to 100 ohm, R3 is equal to 1000 ohm connected in parallel, then your R equivalent must be less than 10 ohm. So these 2 points are the very important point in the case of parallel resistors. Now the current through resistors are I1 and I2. That is, where I1 is current through resistor R1 and I2 is current through resistor R2. The value of I1 we can find out from the equation like the opposite resistance divided by total resistance into the total current. That is, here for I1 the opposite resistance is this one, R2. The total resistance is R1 plus R2 into total current is I. So this gives you the value of I1. Similarly, your I2 is, again the opposite resistance for I2 is your R1. So it is R1 divided by R1 plus R2 into the total current I. Therefore, the formulas are I1 is equal to R2 by R1 plus R2 into I. Similarly, I2 is equal to R1 divided by R1 plus R2 into I. Let us see some examples to find out R equivalent. So in the example 1, a circuit is given and we need to find out the R equivalent of this circuit. In order to get the R equivalent value across this terminal, we need to reduce the circuit from the opposite end. So on seeing this, we have this 4, 5 and 3 ohm resistors are connected in series. Therefore, we get 4 plus 5 plus 3, which is equal to 12 ohm resistor. Therefore, the circuit can be redrawn as 2 ohm, 3 ohm, 1 ohm, 6 ohm, 4 ohm and a 12 ohm resistor. Now, this 4 ohm and 12 ohm resistors are connected in parallel. Therefore, our equivalent of this 2 is 4 into 12 divided by 4 plus 12, which gives you 48 divided by 16, it is 3 ohm. Now, again this circuit becomes a 2 ohm, a 3 ohm and at the end a 3 ohm. So this is 3 ohm, this is 2 ohm, 6 ohm and 1 ohm. Now again these two are in series, which gives you 3 plus 3 equal to 6 ohm. Therefore the circuit becomes 2 ohm, 1 ohm, 6 ohm and another 6 ohm. Now we have two 6 ohm resistors connected in parallel. Therefore the equivalent becomes R divided by N. Here N is 2, so 6 divided by 2, which gives you 3 ohm. And finally the circuit becomes like this: 2 ohm here and 3 ohm here and 1 ohm here. The R equivalent is 2 plus 3 plus 1. Since all are connected in series, we have 6 ohm. Therefore, the final R equivalent value is 6 ohm. Here, now in order to reduce this, we need to reduce the circuit from the remote end. For that, we have these two resistors are connected in parallel, and with that, this resistor will be connected in series. So the parallel will become 20 cross 5 divided by 20 plus 5, which gives you 100 by 25, F4, and that value is connected in series with the 1 ohm. Therefore, 4 plus 1, which gives you 5 ohm. Therefore, the circuit becomes 8 ohm, 9 ohm, 18 ohm. Here we have 5 ohm, here 2 ohm, and this is 20 ohm. Now again, it's 20 ohm and 5 ohm resistors are connected in parallel, that value of equivalent is 4 ohm again, and is connected in series with this 2 ohm resistor. Therefore 4 plus 2, which gives you 6 ohm. Similarly, these 18 ohm and 9 ohm resistors are in parallel, and that equivalent value will be 162 divided by 27, which gives you 6 ohm again. Therefore, that equivalent circuit becomes 8 ohm and two 6 ohm resistors connected in parallel. And these two 6 ohm resistors now connected in parallel will give you a equivalent resistance of 3, and that 3 is connected with this 8 ohm resistor. Therefore, your R equivalent is equal to 8 plus 3, which gives you 11 ohms. So for this circuit, that R equivalent, which is RAB, is equal to 11 ohms. Now, an example for the voltage or current division rule. The given circuit, we have 12 volt input supply and having a resistor of 4 ohm, 3 ohm and 6 ohms. Here we need to find out the value of I naught and the value of V naught. In order to find out this value of V naught and I naught, we need to find out what is the total current, and for that we need to have the R equivalent value. The 6 and 3 ohm resistors are connected in parallel, and the resultant equivalent value is in series with the 4 ohm resistor. Therefore, we have 4 plus 6 in parallel with 3, which gives you 4 plus 18 divided by 9, therefore 6 ohm. Now in the circuit, we have 12 volt supply and an equivalent resistance of 6 ohm is connected like this. Therefore, the current I becomes 12 divided by 6, which gives you 2 ampere. Therefore, the total current is 2 ampere. Now we need to find out the I naught, which is the current flowing through 3 ohm resistor, and the voltage V naught across 3 ohm resistor. In order to calculate that, the total current which is flowing here is 2 ampere, and therefore, according to current division rule, I naught is equal to the opposite resistance 6 ohm divided by the total resistance 6 and 3. It gives you 9 into total current, which is 2, therefore 4 by 3 ampere. Therefore, current flowing through this resistor is 4 by 3 ampere, and the voltage V naught is given by the voltage across 3 ohm resistor. We can write it either by I naught into R formula, that is I naught is 4 by 3 and R is 3, which gives you 4 volt. This is by using Ohm's law. Or for the voltage division rule, we know that this V naught is the same across 3 ohm resistor as well as 6 ohm resistor, since they are connected in parallel. And this V naught can also be found out from the voltage division rule. So before applying voltage division rule, we need to reduce the circuit, because the 6 ohm and 3 ohm resistors are connected in parallel. So the voltage across 6 ohm resistor is again V naught. Since they are connected in parallel, the voltage across these resistors are same. For this circuit, we can reduce like this, and the value is 4 ohm here, and here it is the 6 and 3 are connected in parallel. We have 6 cross 3 divided by 6 plus 3, which gives you 2 ohm. So therefore, here V naught and here it is V1. Now we need V naught as the voltage across 2 ohm resistor divided by total resistance 2 plus 4 into total voltage is 12, which gives you 2 by 6 into 12, 4 volt. Therefore, your V naught is equal to 4 volt. So in this way also, you can find out the value of V naught by applying voltage division. In example 2, we need to find out the voltages V1, V2, the current I1 and I2 in the given circuit. So voltage V1 is the voltage across 12 ohm resistor, and V2 is voltage across 40 ohm resistor. Similarly, I1 is the current flowing through 12 ohm resistor, and I2 is the current flowing through the 40 ohm resistor. So before going to find V1 and V2, we need to reduce the circuit, as this 12 ohm and 6 ohm are connected in parallel. The same voltage V1 will appear here, and similarly this 10 ohm and 40 ohm are connected in parallel. Therefore, the same voltage of V2 will be appearing here. Therefore, by reducing this circuit, we can draw as like this. Now, what is the value here? Here, we need to find out. This 12 and 6 ohm are connected in parallel. Therefore, 12 into 6 divided by 12 plus 6, which gives you 72 divided by 18, which is 4. Therefore, here it is 4 ohm, and here is 40 cross 10 divided by 40 is 10, which gives you 400 divided by 50, which is 8. So according to voltage division rule, V1 now is voltage across the 4 ohm resistor, and here it is V2 is the voltage across 8 ohm resistor. Therefore, V1 is equal to 4 divided by 12 into 15, which gives you 5 volt, and V2 is equal to 8 divided by 12 into 15, which gives you. The next is to find out the value of current which is flowing through the 12 ohm resistor and 40 ohm resistor. For that, we need to find out the total current which is flowing from the circuit. Again, the reduced circuit we obtained is like this, and the current which is flowing in the circuit I is given by 10 divided by 12, which gives you 5 divided by 4. Therefore, the total current coming out of this circuit is 5 divided by 4. Therefore, in order to find out I1, we need to apply current division rule. That is, I1 is the opposite resistance for this is 6 ohm divided by the total resistance is 12 plus 6 plus 18 into the total current is 5 by. By reducing this circuit, we will have 5 by 12 ampere. And to find out I2, here in this node, the total current coming is 5 by 4 ampere. Therefore, by applying the formula, we can have this is opposite resistance of 10 ohm, and the total resistance is 50. The total current is 5 by 4, gives you 1 by 4 ampere. Therefore, the current which is flowing through that 12 ohm resistor I1 is equal to 5 by 12 ampere, and the 40 ohm resistor I2 is equal to 1 by 4 ampere. If you have any queries on voltage and current division rule, you can send a mail to kgcenterforlearning@gmail.com, or you can comment in comment box. Thank you.